Okay, guys, we will be Allah Allah. Tanrı'nın kuralı gibi kalmış burada. Neyse kalacak artık tabii ki. So our purpose of the technology, as I said at the beginning, is to enhance the quality of life. Generally, we want better living space, better nutrition, eating facilities, better education. So all we do in terms of technology is for human use. Actually, the definition of technology versus science is technology is the use of science for the use of human, So if you are going to use the scientific knowledge to make things working for the people, then good or bad, for the people, then it will be technology. It will be called as technology. So that is what we are trying to make. That means at the end, the human is concerned. That's a TV set from 1939, I think. The tube is vertical and there is a mirror, so you watch the TV from the mirror screen to make it horizontal appearance. That's another TV supposed to be. So the term man-machine interaction, the performance of the human, is concerned starting with the wars. Easy to use weapons became more successful, especially in the Second World War. The equipment became so complex so that the soldiers couldn't use them in the airplane. They couldn't use them. Every week, every month, new advances were invented by the forces, by the Germans and by British and Americans. They included them into tanks and airplanes, but the success rate didn't increase. And they investigated that and understood that although the things were available, pilots and the shooters, bombers, they were not able to use them successfully because of the complexity. The device was there, but it was impossible to use. Same thing occurred in complex industrial equipment after the Second Industrial Revolution. Easy to use devices increased the productivity. So the ergonomics and other issues, other terms came up for the industry. And house appliances, computers, automotive, they all suffered because the parameters are increased. They all suffered from the human performance problems as they became more complex. For the motivation of this class, there are some disasters. I will talk about them, others also. This is one of them. There is a plastic recycling factory there, and there is a guy inside who is cleaning the tank, but the other worker started the equipment without realizing that there is a person in the tank. obviously the guy has been died. So the reason is the user interface, the system design. If the system design was correct, then it would be impossible to start the device with a person inside. So your design should prevent that. From time to time, we hear some airplane disasters, and airplane disasters are usually attributed to pilot errors, which is very famous in our discipline in human-computer interaction. We say, it's in the coming slide, we say there is no human error. We say there is no human error. We say error is human. Error is human means human will make errors, which is normal. Yani insanidir hata. İnsani bir özelliktir. Human make error. So as a system developer, you should design the system so that that error, any kind of error, will not cause significant damage or harm to anybody. So if you cannot do that and rely on the error freeness of the person, then sooner or later, one day, you will fail. In that airplane disaster in Sparta, I think 6 or 9 physicists, famous physicists, has died. One of them was my professor when I was in college, Engin Arık. The problem is, pilot believed that there is a runway ahead. Actually, it was the mountain. So these kind of errors are actually big ones, but there are also small ones, like small traffic accidents, incorrectly configured phones, big finger problems when you are sending money. You are sending money to your friend 1,000 Turkish liras, but accidentally you are sending 10,000, and he's not giving you back your money. So that kind of problems may occur, of course. Also, sometimes things that may take half a minute may take 5 or 6 minutes, 10 minutes, because of the difficulty and lack of understanding of the user interface. You are lost, you start again, try the same thing, doesn't happen, then you realize, oh, it must be the other way, so it will consume your energy. Another famous Air France accident happened 5 or 6 years ago. 228 people. There was one Turkish woman who was a musician going for a concert in South America. You may remember that. You were in high school, and it was a big plane, I think 777 or something, or Airbus 330, big plane, with 3 pilots. One pilot was sleeping normally, which is fine, and 2 pilots were flying. And because of the instruments, one of the instruments was giving incorrect error. 2 pilots, it was night, so you don't see anything from the window. One instrument is saying that your speed is low. Another instrument is saying that your speed is high. Which one is correct? And they couldn't differentiate whether it was slow or fast. It's going like that. They started arguing about this airspeed. People listened that after the accident from the black box. They argued about 3 minutes. One of them is saying we are going too fast. The other one is saying we are going too slow and we will fall. So then the pilot started to pull the yoke so that it slows down and becomes normal. And they started climbing. They climbed, and suddenly airspeed dropped, and they lost the flight. During the argument, third pilot woke up, came to the front because the plane was making unstable movements, and he also started arguing about what is happening, etc., etc. And three of them couldn't decide whether the plane is going fast or slow, and the plane crashed. That is significantly the result of the instrumentation. If the instrumentation gave correct output, then it won't happen. It wouldn't happen. Similar accident, because of not correctly appreciating the computer readout, happened 2 years after that in a Turkish plane, Turkish private jet, full of girls, like 10 girls going for their birthday party over the Iran. The pilot was also a woman, and they were going for a party in somewhere, I don't know. And similarly, same kind of accident. The pilot think that it's going so slow, so fast, and tried to increase the nose so that it becomes a little bit slower. But actually, she was doing the opposite, what was necessary. And it is also because of the incorrect instrumentation reading, incorrect understanding of what is happening. The errors that we make in our life also similar. Nobody wants to make mistakes. Think about yourself. Once you make mistake, the cause is probably due to incorrect understanding and incorrect representation of the problem to you. So you understood the problem. Your model is incorrect, and you are acting based on that model. If your model of the environment is incorrect, for example, the relations with your friends too. If the model is incorrect, your act becomes incorrect, and it may cause disaster. Whether you are using it for personal relations, in the class, in solving the question, or in the traffic. You have to create correct model of the environment, and you have to run that model to predict what is going to happen. And based on that prediction, you need to give output to the environment and wait for the result. Otherwise, you'll make mistakes, you die. Recently, there was a ship sunk in Marmara, and I couldn't believe all of them. I think one was found. Most of them has died in Marmara Sea in a ship, which is, I believe, ridiculous, because they cannot estimate the danger. Their model in their mind is incorrect. In the books, there was a famous 1992 accident, Airbus accident. after this accident, Airbus replaced all these devices in the cockpit. That device. And you see, it shows 2.8 here, right? That 2.8 means sometimes 2,800 feet per minute, decreasing 2,800 feet per minute decrease. So it's a vertical speed, or 2.8 degree vertical angle. The airplane can go down in two different modes, vertical speed or flight position angle. That is set by here, VSFPA. There's a switch here. Depending on the switch, this meaning changes. It could be vertical speed or FPA. And by adjusting that, pilot approaches the runway. In this accident, pilot thought it was in angle mode, but the device was in the vertical speed mode. So it was in different mode than the pilot thought. Is it a pilot error? Apparently, yes. But if the device is differently designed, it could not be a pilot error. Therefore, they made experiments after the user interface experiments after the accident, and realized that people are making errors. So they decided to replace it with 4-digit display instead of 2-digit. So if it was 2.8 degrees, it was giving 2.8. If it was 2,800, it was displaying 2,800 actual value. Then that problem never occurred again, except one plane and the passengers was lost. This is another example I have been showing to people. This is paper cutter. Let's see if it works. You have to put your both hands to the buttons so that the system makes sure that your hands are away from the place. Otherwise, you will lose your fingers one day.
Clamping or clamp and cut.
Okay, good much. That's why you have two different button set on the left and right. So that is by design. The question is, our technology is improved. At some point, the variables that we control are too complex compared to the old tools and technologies. Obviously, I am not blaming the old guy, the medieval guy, because it also requires some mastering. But the things that you need to learn, you need to read the manuals, are quite complicated. So interfaces must be improved to overcome this problem. The problem is on the interface. Older days, at the beginning, people were saying, also in the computer programs, if it works, it's okay. So I see most of you developing programs in Python and showing us the graduation project in the Python development environment. But in real life, it's not the case. You need to develop an application. You need to develop an interface, right? So if you grow up like that, if it works, it is okay, the user interface is not important, etc. Your program may be very good, but you cannot sell it. And end user performance will be very bad. because the ability of your code is fine, but interfacing is not as good. Therefore, at the beginning, the left one is the steam locomotive. The controls are quite awkward because it is the Python level of the control and interfacing. They made it running, they installed it in the airplane, they finished it. But today, it's much more simple and advanced, especially new Boeing airplanes and Airbus. Starting with the Airbus, it's all automated, and things that are not required are not given to the pilot. So interface is much more automated. The difference between Airbus and the Boeing type airplanes are significant. One of my old classmates is working in Pegasus Airlines. Recently, we have been talking. Pegasus is switching to Airbus recently. They are selling their Boeing jets and switching to Airbus because of, I think, he said they consume less fuel and they are more efficient to operate. He was unhappy by the Airbus. He wanted to be in the control of everything. He was an army pilot, ex-army pilot. In the Boeing, he says, you switch something from here and something happens in another place as a result of what you did. So in Boeing, he said, it doesn't happen. If you do something here, these things only change. He was complaining about it, but apparently, in terms of user interface and software engineering practice, Airbus is given as a big improvement over others in the literature. Same brand, same size. The complexity increased because the things that we control increased. However, today, that trend is reversed. Today, what we see is closing the interface to the end user so that many things can be automated by themselves. So recent car radios are not like this. Recent car radios are becoming, again, simpler because they are so intelligent that they understand what user will like. They automate certain process, so manual control is not necessary anymore. Some old cars have voltage displays. The new cars don't have voltage displays because it is so improved that that problem is not an issue anymore. That is not a problem anymore. If there is a problem, the computer will display a message saying that you need to change the battery soon, something like that. You need to change the oil. So they don't put oil pressure gauge to constantly monitor by the user, by the driver. Because in the older days, there is no computer. The driver has to monitor the pressure of the oil, the voltage, etc. So by looking at the behavior of the needles, he or she has to estimate what is going on, engine temperature, etc., etc. Now, they are all gone because the system, there is a microcomputer in the car is taking care of it, and if it is necessary, it is giving the message in the display. So those displays are gone and hidden from the user because they are not necessary anymore, which is good. Sıkmıyorum, değil mi? Oh. This is B-52. Last time they used it on the Iraqi war. It is Second World War plane and still in operation in some places for some certain reasons. Once you pass technical limitations, then you focus on the usability part because the performance doesn't improve anymore. Ergonomics, on the other hand, application of scientific information concerning objects, systems, and environment for human use. So systems, environment for human use, objects. It's not only software. It's a good term and mostly hijacked by, I will say hijacked, mostly hijacked by industrial engineering departments and also in architectural departments. The software ergonomics is not very common in our discipline because ergonomics deals with the efficiency and performance. But when we say user experience and human-computer interaction, people will slightly deviate towards taste and liking the interface, satisfaction, and sort of. Ergonomics don't pay attention to that. I mean, didn't pay attention to those topics in the past. So ergonomics is more related to it's perceived as more industrialized and product-oriented thing. However, they are the same. Not only workplace, but also end user. Human-computer interaction is concerned with the design, evaluation, and implementation. Three things: design, evaluation, and implementation of interactive computing systems for human use. So, since many things are computerized today, the cars, the projectors, and the laptops, and the mobiles, even this has computer chip inside. Therefore, in order to open certain things, I have to press, for example, twice. So there is an interface here. Therefore, HCI and ergonomics are interconnected. Similar to Blaupunkt radio that I have shown, this is another example of progress in washing machines. At the beginning, there are not many variables, just plug and turn on. Later, they invented cartridges. Here there are cartridges, and those cartridges correspond to programs, and the cartridges contain hardwired program, and the corresponding program is executed, like water temperature, amount, etc. If you lose the cartridge, you lose the program. New ones are more complicated with the screen, which is interactive. So a lot of variables. But some brands are going back. They are going back by sensing the material inside, sensing the amount of load inside. Therefore, for example, sensing the material means you don't have to set it manually. It is automatic. Sensing the fullness of the machine, automatic. Therefore, you don't have to press 3 kilo, 5 kilo, 7 kilo, etc. So those controls are slowly being eliminated, which is good. It also depends on the culture. Some cultures are requiring more control. Complex looking things can be perceived better in some cultures, especially that's true in Asia. In China and Japan, they want to have more controls, more buttons. In the Europe, people don't want more buttons, they want less. Therefore, manufacturers open up design studios or make agreements with the design studios in Italy or France, Asian manufacturers. They change their design based on the European customers. So it's also, as I say, it's also a cultural thing. This is an example from Japan. So it's again, washing machine, which is too complicated. 2 months ago, I was in Korea. The toilet was very interesting. It was an automated toilet in the hotel room. It was a cheap hotel, a 3 or 4 star hotel. There are like 10 different buttons, electronic buttons on the closet. So only one of them was flushing. Others are for other things. So they want control buttons to control all the variables. Consumer appliance interaction has been around also as a factor. Many HCI books use the term usability of daily appliances. For example, Donald Norman's book, usability of everyday objects and equipment when explaining usability term. For example, the doorknob. For example, this. Do you think İbrahim Soğukpınar can turn this on? No. It's a simple issue. So this is wrong. I mean, I'm not a tall person, but I'm an average person. I can barely reach the button. These lights, they all are interfaces. This one is an interface. When I look at this, I immediately understand, based on my previous experiences, I can open it by holding and pushing it. I'm not pulling it. If it was inside, I was probably trying to pull it to the inside. We made it opening to the outside as we designed this building because it's a school building, and the guy who is making the doors couldn't believe it. They didn't want to make it because they said it is in the opposite direction, hocam. We say it has to open outside because in case of emergency, people will accumulate here and you cannot open the door. It has to open outside. They made it. However, they made it the same for the labs, which became insecure because you can take the hinges out. Take the hinges out and the door comes as a complete set. So it takes time to get used to these interface things, but when you look at an interface, you need to, interface should provide cues to figuring out things. For example, I want to turn it on. Here, it is red. Red is usually associated with an pen, sometimes error, sometimes an operation because it's a cheap LED, has been around. So I would make it blinking if there is an error, and normal if I can do it with green. Today, because there are multiple color LEDs, and this is an option cover, which is also available in the software. When you click on more, this opens up. Click more again, it closes. But the most important thing is it has to work. One of the reasons of having problems with these climate control and climate system is they installed the most expensive control panel. There were cheaper control panels, but cheaper control panels were not giving sufficient profit margin to the seller. So they wanted to sell the most expensive one so that they can profit more. But the problem is, since they didn't instruct us or train us or protect these from use, people played with these configurations, and the central computer, second floor, switched to the error mode. So only on, off, and temperature were sufficient. The simpler controller were sufficient for the class use. At the beginning, these computers didn't have. Ne oldu?
Toplantım vardı.
Yok var. Toplantı var. Ama yoksun geldim. Toplantısı olanlar gelmesin dersin.
Ara verebilir miyiz?
Verelim biraz abi. 10 dakika ara verelim. 10 dakika ara verdik Erkan.
Hocam soracaktım da ben 2 ders aldım. 2 ders aldım. Bir sizin dersinizi aldım. Bir algoritmayı aldım dediğim.
Toplam ama zamanlama yüzünden mi?
Yok. 3. bir ders de alacağım ama günler belli olmamıştı ben size sorduğumda. Şimdi günler belli. Ders ekleme çıkarma zamanında mı bunu yapayım? İlk sorun bu.
Bugün de yapabilirsin. Bugün yapabiliyor musun? Daha
Onayla size onaya düştü herhalde. Hatta onayladınız bilmiyorum.
Akşam onaylarım ben ancak.
Tekrar seçebilir miyim oradan bilmiyorum ama. Kesinleşme oldu herhalde.
Eklemeyle yaparsın. Açılacak.
Onu o zaman olur değil mi? Bir de bu seminer işini nasıl yapalım? Seçeyim mi? Alayım mı? Almayayım.
Al.
Alırsam bir de o 1'e inecekmiş herhalde.
1'e indi.
İndiyse
Bir tane kalabilirsin yani. Atıp şey yapabilirsin.
yani bu dönem mi alayım,
Kalmak
öbür
kolay.
dönem mi alayım o zaman?
Öbür dönem son dönemin mi?
Hayır. O 2. dönem.
O zaman öbür dönem al.
Yani 2 dönem daha var.
Tamam öbür dönem al.
Yani bu dönem 3 ders alayım o zaman.
Öbür
Ben
dönem
zorunlu.
al. Evet.
Peki ben bu derslerin zorunlu olup olmadığını o şeyden mi seçeyim? Ana dersler diye bir şey var.
Evet, 4 dersten 3'ünü alıp 2'sini geçeceksin.
Ama hangilerini alacağım bilmiyorum.
Sen karar vereceksin.
Ama orada bir seçmeli falan var ya, bu bizim bölümde açılan derslerden mi yapmam lazım? Burada
Evet,
bir zorunlu mevzusu var ya.
Bizim bölüm zorunlu dersler algoritma, operating system, discrete matematik, bir de architecture.
Architecture'da mı zorunlu?
Seçebiliyorsun.
Ben seçebiliyorum.
İkisini geçmeniz gerekiyor.
Tamam, teşekkür ederim.
Dilekçe.
Hı.
Bir tanesi etik hocam, ön koşul şeyi. Bir tanesi de ben bu dersi resmi olarak ekleyemedim. 2 tane seçme ders eklemem gerekiyordu.
Hangi ders için?
Bu bir tanesi OS için hocam.
Yazmıyor.
Pardon, bu seçme ders.
456.
Bu dersi ben resmi olarak ekleyemedim. Bir tek
Niye?
Yusuf Hoca'nın dersi uyuyordu ders programına ve onda boşluk vardı. Bir de bir tane daha uyuyordu database sanırım ama onda
Kontenjanında
boşluk
boşluk olan derslerden bir tanesi ders programına uymaktaydı.
Onu ekledim ama ikinci olarak bunu ekleyemedim.
Niye? Kontenjan doldu.
Evet.
Doldu.
Hocam
Başka bir-
yani sistem yine dondu. Yine aynı şey yaşadım da ben. Başka bir ders uyum yok hocam.
Sistem dondu mu?
Evet.
Sistem donmadı canım.
OBS dondu.
Yok, donmadı.
Bir tek ona dondu hocam. Herkese dondu lisanstayilerde. İsterseniz arkadaşlarına getireyim sorayım size ama.
Olmuştur, tekrar
Sıkıntı
açılmıştır.
olup şey olmuş hocam. Uzattılar ya ders eklemeye hatta.
Hocam şöyle bir şey oldu muhtemelen. Hani siz mail atmışsınız da 4. sınıfta işte ilk gün yapsın vesaire
Evet.
ama sistemde bir engelleme yoktu sanırım. Herkes
Yo, onu yaptılar. Önce de öyle oldu.
Çünkü çoğu arkadaşım seçemedi ya da ben mi? Hani ilk 40'ta değildim ya da bilmiyorum.
Sen ilk 40'ta değilsin. 40 kişi almış. Ben dersin kontenjanını niye arttıracağım? Ben onu anlamadım.
Ders seçemedim. Neyse tamam. Yusuf Hoca'nın
Danışmanın ben miyim?
Evet hocam.
Kontenjan konusunda. Ben bu dersin kontenjanını arttırmamaya yemin ettim de onun için.
Tamam, farklı bir ders yazayım o zaman. Bir tane daha yapayım.
Konuşulacak.
Yemininizi bozmayayım hocam. Farklı bir ders yazayım. Sarp Hoca'nın dersi var. Uyan.
Uygun bir ders. Ders alabilmesi lazım. Bu ha. Ben bunu daha önce imzaladım.
Algoritma için imzaladınız.
Geçen hafta.
Geçen dönem algoritma imzaladınız. Onu geçtim ben. Algoritma sıkıntı.
Yok, başka bir arkadaş.
Ha, tamam, başka arkadaş olabilir.
Aynısını imzaladım birisi için. Var mı tanıdığın?
Bursu olabilir.
Bursa Erbirgit.
Aha,
Olabilir.
Bursa ben geçen dönem yapmıştım da. Ben derste kalkabilirim mi? Dinlemek için.
İnşallah alırsın, konuşuruz. Hani o kadar yemin de ediyorum ama
Çünkü yani Yusuf Hoca'nın dersinde...
başkaları da şey yap, başkaları da şey yapıyor, bastırıyor şey yapmak için. Hani sen birinci böyle gelmiş, imza attırmış, ondan
Anladım hocam.
istemiyorum.
Teşekkür
Yani.
ederim, çok sağ olun.
Hocam,
Ben
kolay
benim
gelsin.
şeye...
Danışman ilişki yapmıştık hocam, hatırlarsanız. Yansımamış sistemini. Hoca da görünüyor. Önemli değil mi? Hocam onaylasın. Derslerimi söyleyeyim mi hocam? Machine Learning, Deep Learning.
İkimize mail at.
Mail atayım.
İkimize beraber mail at.
İkinize birlikte. Tamam hocam. Tamam. Hocam tez görüşmelerini ne zaman başlarız? Bu dönem seminer 1 alıyorum.
Seminer 1 alıyoruz.
Evet.
2 hafta sonra falan.
Tamam. Materyalsiz mi belirleyeceğiz?
Seminerleri
Birlikte mi belirleyeceğiz?
birlikte.
Tamam. Tamam.
Sistemde şöyle bir şey oldu. Mesela dersi ekliyoruz. Bir tane ekliyoruz da sistem bize hemen atıyor. Tekrar giriyoruz.
Anladım.
Şey olana kadar-
Düştüğü için siz o zaman daha çok atıyor. Daha çok yükleniyorsunuz. Daha çok atıyor.
Evet,
Çünkü.
birden farklı tarayıcı da denedim. Hani bir sürü arkadaşım da var da ben seçemedim de son dönemlerim artık. Benim tamam seçmem. Teşekkür ederim.
Çay da alıp geleyim. Ya alayım dur.
Dersler öyle deli değil.
Doğru.
Online olması iyi olmuş. Öyle de oluyor. Memur aslında kural oluyor da yanlış okulda. Ne?
Çok kafa görünce.
Diyorum yanlış okulda.
Sistem sende doğru mu derdi zaten? Seçmenleri
Bir önceki şey değil gibi evet.
Bir önceki gibi oldu yani.
Aynen.
Tek bana olmadı. O yüzden doğru.
Geliyor 30 saniye
Ha.
seçebiliyorsan seçiyorsun sonra Gidiyor size. Biraz bekliyorsun tekrar açılıyor falan.
Çünkü ben bu dersi seçemedim. En son mecburen sistem onaydan böyle bir kredinin altında olduğu için hani Yusuf Hoca'nın seçmesini ekledim ve ondan çok korkuyordum açıkçası. Ama
Buradan ders alınmaz.
mecbur kaldım. Ondan çünkü diğerlerine kaçacaktım bu sefer.
Dilekçeyle mi alıyorsun?
Söyledim ama hoca dedi ki ben yemin ettim ders kontrolü verdim olmayı dedi. Yerine oturduk gelecek üstüne işte uygun olan bir tane ders eklenmesi diye de benim tek bu uyuyor ders programıma. Yusuf Hoca uyuyor. Bir de Sarp Hoca'nın ikisi uyuyor. Sarp Hoca Yusuf olan için onda da şey yok. Onda da kontenjan yok. Ya onun için bilet vereceğim ya bu ders için. Sen integratif var mıydın? Ne yaptın? Geçti mi? Helal olsun. Ben kaldım. Ben böyle düşünmüşsün. Onun yerini alıyorum işte. Ya onun yerine Yusuf Hoca ikisini aldım. Yine kalırsam efektten pek bir şey düşmesin diye. Yeni bir şey olarak bunu aldım.
Hocanın san notunun mezun olduktan sonra öğrenebilirsin.
Hala NLP açıklamamış.
Evet öyle şeyler varmış.
Dersler sen olsun oldu mu? Nerede? Nasıl?
Online.
Kolay mı?
Online evet. Yani tamam işte yani nasıl? Hocam burada
Burada bir yıl okuyor da çıktım ya. Bak ya sen gel ortaya. Arkası çıktı toplantıya hoca gelmedi. Sen derste mi?
Yok ben dersteydim.
Bir de 5 saniye önce çıkmadı mı tam dersi bitirdim? O çok iş mesela.
O toplantıda komşum arada hocası gelmedi. Sonra şey var aradı işte. Garip bir durum.
Takip ettim.
Olasılıkla hoca sınavdan önce süper sorular sorarak gibi bir şey demişti.
Ya ben söylüyorum ben.
Aynen.
Teorik competition. Onu da öyle.
Olasılık için soru theory competition için.
Bu normalde benim tarzım yok. Bazen sınavdan
Bir de
önce
okuluk
sorular.
yapıyor gibi bir şey var sanırım.
Online'da var mı?
Online'da
Bir şey var mı ya? Evet yani. Kasmıyordu yani.
İyi hoca ya.
Vizesiz biraz zor. En çok kolay. Online. Bu bir şey güzel.
Ama güzel değerlendirirsin. Dokümentleri, reklamcıları koyuyor. Şu an güzel renklendirirse. Onu güzel yapıyorum ben sana. Farklı bir şey. Yani. İyi denenir. Denenir. Divider'ımız. Aynen öyle. Böyle iyice daha şey oluyor. Wire. Aslında bir wire reklam da. Tüm olay değişiyor. Yeni ben
Beğendim aslında beğendim hocayı.
niye de kadar bence gibi.
Bence de iyi. İşte yuvarlak çiziyoruz. İşte bir oraya gidiyor, oradan ona gidiyor işte. Bisikletin aynısı. Çok kolay ders. Ben çözdüm kanka. Valla. Gelip bana şey diyor. Projelerine başlıyorum. Bu konunun sebebi bir derece. Adam yaptıysa veya zor bir proje. Bakıyorum diyor yok konuda. Gelmişsiniz veya yapıyor. Gelmişsiniz veya yapıyor. Aynen.
İnsan o hoca, team leader var ya, hoca ders alırken senin bilgisayarını almak istiyor diyor.
Niye aldın?
Ses geliyor senden işte ama her şey ona kesin ağlıyor.
Bu ne olmuş?
Bunlar öyle bir şey bırakmış.
Şimdi online ders olayına ne diyorsunuz? Hiç respons vermediniz ya. İyi mi?
Almayı yok.
Nasıl geçti anlamadım.
Ya.
So burası acıyor. So in the old days, as you already recognize, smoking pipe was common among computer programmers and engineers. The first computer class I took is in Boğaziçi University in 1986. It was Fortran, and the guy who was giving the class from the nuclear engineering department recently passed away. Vural Altın was smoking pipe during the class. So it was also common, some professors smoking during the class as well. In our time, one of our professors, who was very famous, Cem Göknar, was asking cigarettes from the students during the class. The interesting thing here is there is no screen. Input and output is all through the typewriter. Input is typewriter, output is also typewriter. It's an electric typewriter. So if the commands are coming from the server, then it's output. Today, too many information is coming to the person, and understanding those information and accumulation of those information is a big challenge. Almost all products in the market have similar functionality and quality levels in terms of hardware, but the consumers make their choices based on the brand, external look, the rumors, satisfaction, and etc. So this look, other users' experiences, and user performance, usability, and user satisfaction. Satisfaction is also another thing. Determines the purchase of a product, software product. Therefore, usability and ergonomics play a significant role in that part, maybe more. When we work with good interfaces, project development becomes easier because interfaces are standardized, training costs are lower, improved use is provided, and you reach to the better sales. With the bad interfaces, training requirements increased, users can get bored, efendim. Z11 tabii. Z11'e gelebilir mi? Ben dersteyim şu an. Sağ ol. Daha varmış. Users can get bored, frustrated, and we can have data loss. We can input incorrectly, and sometimes stop the using appliance or feature. For example, old people are having problem with smartphone use. So they say they don't like it. Actually, it is not the thing that they don't like it. They cannot use it, but they don't want to admit it. At the end of the day, they say they don't like it. They are unable to use internet. They are unable to use certain features because they cannot use it. And they don't say it directly, but they say they don't like it. They don't need it. Some old people don't take their phones to mosques in Anatolia. And we looked up about the reason, and the reason was they don't know how to turn off the sound. Since they didn't know how to turn off the sound, they found a solution. They don't carry it. So the easy solution is not to take it. For example, they say they prefer to get the money from the bank instead of the ATM machine. They say they like it, but actual problem is they are frustrated in front of the ATM machine. They don't know how to use they are having trouble using ATM machine. Then they say they don't like it. They don't need it. It's not secure, etc. So the basic problem is the interface. Once, maybe some of you have heard, I was in Gebze and I was in the line of ATM. One woman was following the guide directions, trying to get the money. And at the end, there was a dialogue saying onay. Onay iptal. Amount of money, like 100 lira or whatever. Kalem var mı? 3. Bu kadar mı ya? Bu taraf. There was an onay and iptal. And onay was meaning confirm. But it is in the new language. And the woman was keeping iptal, cancel, about 3 times. She was entering 100 lira, continue, and when they reach onay, confirm, she was pressing cancel. I approached and said, onay means tamam. Then she said, okay, now I understand. So the problem was the language. The problem was the word was not understood by that type of person. Although it was in Turkish, it was a new word, young generation word, put there for everybody by a young programmer, but the old generation couldn't understand it correctly. Similar thing happened in Finansbank Gebze. The old guy was in the bank. The security guy directed him, amca butona bas to get the number, order number. And he didn't understand. Was looking around. Amca butona bas. I intervened. Amca düğmeye bas. And he understood. And the security guy talked to me, but the düğme is gömlek düğmesi. That's the button. That's button, not düğme. I told him, what is the word in English for the düğme? That's the button. So it's the same thing. Sometimes language barriers create problems for many users, especially elderly people. So as a programmer, if you are dealing with public interfaces in your work, you need to pay attention to that too. This was an old example. I collect these information. Windows security is turned on, and this says close. For non-native speakers, it doesn't make any sense, but this means turn off. So it says turned on, turned off. So but this should be okay, not kapat, because kapat and aç and kapat, these are antagonist words and creates problems. Or etkinleştirildi. Another problem from the İş Bankası, the banking application. You fill your social security number, your first name, last name, and telephone number to apply for the internet banking or something like that. And this dialogue came. And this dialogue, this was a very famous. Bankamız ürün ve hizmetlerine gösterdiğiniz ilgiye teşekkür ederim. Thank you for the appreciation, and please, for the following form, please fill the personal information, and after filling these information, filling these information, then there will be additional questions. After each form, there is a continue and back buttons, or on the left, there is a list for kişisel, personal, and product information can be looked at, and you can change the information you enter. Where? Doldurduğunuz bilgiler, the information you've filled, ilgili şube elektronik ortamda edilecek, will be sent to the bank, and the bank will contact with you. Thank you for your patience. What's happening? This, I applied İş Bankası first time with this interface. And I filled it, and immediately I see someone teşekkür ederiz. So if he thanks me, then I say it's finished. I don't see the others. Nobody reads it. The first thing you see is thank you. If it is important, make it important. Or put some continue button here. But after some iterations, I realized that there are things here. You need to click on the tab, fill the information, and there is a submit at the very end, not on the others, at the very end, and you have to click on the submit, which is quite incorrect here. We call it as task closure problem. here the task is closed, finished. That's what I perceive. So when the task is finished, I believe the task is finished, but the interface is not finished yet. Obviously, it will create an error. Generally, you will be developing systems for people, and the system you develop is quite different than the system you have in your desk as a developer. As a developer, you have a big displays. You have big displays, fast machines, very quiet environment, coffee, etc. But here, although there is tea, the environment is different. So you need to understand this environment. Small monitors, a lot of things, a lot of papers, interaction with these papers, people looking at from the top. So constant attention division. You need to talk to other people, be kind, etc. So that one big problem with the Siemens software in Johns Hopkins Hospital next to us was years ago. The developer told me, in the payment screen, the patient comes, gets checked by the doctor, goes out and pays, right? And in the payment screen, they open the record, wrote the information, and pay by the credit card, whatever. And the patient said, my credit card is in the car. My wallet is in the car. Say, okay, but the interface didn't allow to hold that transaction and open another window. Other patients had to wait. Other patients had to wait. There was no saving session, or there is no opening another window for another customer waiting on the line. So apparently, after several months, Siemens changed it because it was different in different countries. They didn't think about it because the environment is quite different than what developer can think. Again, this is from Şeker. This is from Şeker Bank. It was a project, Şeker Bank. The biggest problem we saw here was the monitor was small, and they were unable to read what we put on screen. But that's so simple. Also, what we observed was there was a lot of interaction between calculator, and the result obtained in this calculator was not automatically transferred to the application. So if there was a Bluetooth enabled calculator or something like that, it would be very helpful for the person. So the rest of the class will go through human performance, the human cognition, then good interface characteristics, design heuristics, method of evaluation, method of design, and other things like software development using user-centered software development methods. So principles, laboratory experiments. I have a lecture called for web and mobile. Also, newly there's a lecture set I prepared. Data visualization, scientific visualization. Okay, situational awareness. So new topics are also will be taught. There will be exam. See how things change over time. There will be exam and there will be small projects. For graduate classes, there will be articles, and you will read some articles and write reports or present, depending on how we make it. So the goal for usability studies, why we are doing it, is three: effectiveness, efficiency, and satisfaction. These are the rules. First, goals must be met, so it has to be effective. When you are developing a software for sending money, it has to send money. It has to function without any penalty. Two, it has to be efficient. Efficient means in terms of person. It has to be fast. It has to be less tiring, less demanding for the mental, less demanding for the physical, like this. This is not efficient. Usable, but not efficient. Is it effective? Yes. It is not effective, actually. Stopped. So it's effective. In some old days, they were not stopped and they keep trying to come down. Last one is the satisfaction, the color, the comfort, the beauty. Those parameters play important role in usability. Sometimes it takes a little more time, but since the interface is pleasing, it looks faster and better. For example, there is a short path from when you are walking from point A to point B, short path, but the road is not very good. Bad environment, bad buildings, not very good view. And there is a longer path, which is green through the park, etc. That road is better, more satisfaction is provided. So people use that road because more satisfaction. It's not as efficient, maybe, but it's better. So efficiency, effectiveness, and satisfaction as the three pillars of the usability. These pillars provide different products and user interfaces. Some platforms like ATM machines are woke up and use systems. So at the beginning, there is very little or no experience, but the performance and efficiency should be provided, even you haven't used it before, like kiosks. You don't have to teach how to use kiosk. It has to teach itself automatically. But over time, the performance doesn't increase due to prompting and other features of the interface. It starts to feel slow because it is more mechanical, more oriented towards first-time users. So performance increase and proficiency is limited. Systems for novice users are easy to learn and proficiency increases, maybe not as much. System for expert users are like Linux command line interface, difficult to achieve, but once you achieve high performance, you are very efficient. So there are different types of interfaces. If you have any questions, let me know. Our goal is to create product that should be used effectively, efficiency, and with the satisfaction by the user. Therefore, we should understand human by both psychologically and physically. We should understand tasks, we should understand the environment, social environment, organization, and technical capabilities and limitations. Sometimes people want, let me solve this by AI and let me solve this problem by AI. But once you look up the solution, it's not implementable. You need a big computer, a lot of computational resources. So it is out of the scope of the target. At the end of the day, we are scientists, fine, but we are also engineers. So engineer means there are constraints, and with those constraints, you need to end up with a technological product for human use. If it is not cheap enough, it doesn't make sense. It becomes science. So we will start. I'm not going to go into this week. We will start with the human capacity. Our products become successful only if they are used by the consumers. Therefore, our vision, hearing, and physical limitations and abilities play important role and must be taken into consideration. 95% of the information that we consume is through the eyes. So understanding human eye and human vision is very important factor in usability studies, because you need to see it before you understand it. If you don't see it, forget about it. Sometimes you see it incorrectly. These are the visible spectrum that we deal. Ultraviolet is on one side, infrared is on the other side. The small amount. Some animals can sense a little more towards the ultraviolet range. Not all light sources are creating the same spectrum. For example, daylight is given by dots. Spectrum of the daylight includes a lot of blue and ultraviolet in the spectrum. And we see that light outside as a white light. That is the content of the spectrum. With the light bulb, incandescent light bulb, creates a lot of heat. So it is also creating infrared light and very little blue light. So we see it as a red light in the houses, like candle light, created by heat. With the fluorescent bulb, we see certain spikes in the atomic, depending on the atomic type, or mercury or sodium or whatever. For example, sodium is only one color, yellow. Depending on the atom inside, we see spikes, but generally it is oriented towards yellow. With the white LEDs, like this, these are white LEDs, it goes up, goes down, goes up, goes down. So it's like two peaks. Two peaks are available in the white LEDs. Basically, it's a combination of two different LEDs together. Two different color LEDs together. We see it as white, but it is not as white as the daylight, but because daylight is continuous. In order to see something, light source should go on an object If the object is red, it is said to be red. What is red? Red means red wavelength is reflected. Other wavelengths are absorbed. Paint. Red goes out, and we see it as red. But if it is not white light, if it is blue light, we see it as black, because blue light doesn't contain red. So nothing comes back. Since nothing comes back, it is black. Okay? So it's a function of incoming illumination and the color. It could be illuminated from the back too. This will be the last slide I will be talking about today. Why do we have RGB colors? Some of you may say, because those are primary colors, right? Why are they primary colors? Colors, when we talk about wavelength, it's continuous. 700 nanometers, 400 nanometers, 400, 401, 402, 403. There is no primary color, primary wavelength. It's all continuous. Electrically, it's continuous. No difference. The difference is at our eyes. In order to get this spectrum perceived by a person, over the time, people developed 3 types of sensors in their eyes. Those 3 types of sensors are sensitive to different portions, slightly different portions of the spectrum, so that we can differentiate colors. This is the backside zoomed. These are the cells. These are the prefilters, and this is the retina. That is the inside. This is outside of the eye, back. This is inside. Have you ever seen the picture of your eye after the doctor examined you? Kendi gözünün fotoğrafını doktordan print out olarak alan var mı? Enteresan. Ben bir kere almıştım. Şöyle bir şey alıyorsun. Bir yuvarlak şeyin içerisinde. Bunun fotoğrafını çekiyor. Turuncu. Yani damarları görüyorsun falan. Ama esas muhabbet onun arkasında. Bu biraz zoom hali. Önde kan damarları var beslemek için. So 700 nanometers, 400 nanometers. Which side is blue? Cevap verin. 400. Küçük nanometre, yüksek frekans. O da blue. Tamam mı? Bu 700 1100'lere falan çıktığı zaman bu 1100 ve 2000 arasında kafelerdeki elektrik sobaları, doğalgazla çalışan, bu sizin üşümeyesiniz diye yapılan enerji harcaması. The cells that we have our eyes are sensitive to these wavelengths. Blue cells in our eyes are sensitive this much. They are sensitive to 450 at most. Then their excitation is reduced as frequency changes. The green cell is sensitive to 550. Red cell is most sensitive to 650. Okay? Our brain compares them. As they compare them, we can estimate what is the primary color by looking at their weight. So if you provide an orange wavelength, like 650, orange wavelength here. Takip edebiliyor musunuz? Uçmuyorum değil mi? If you're providing 650, the cells, these RGB cells, which are very dense here, but not as dense around here, are affected electrically with these amounts. And we see that it's an orange, this color. Our brain is programmed to see it as an orange because we saw an orange before when we were a child. If from the distance, if we create separately red, green, and blue signals together with these amounts, those amounts will equally stimulate the cells in similar way. So the net stimulus in the cells will be the same. So I will say I am seeing orange even if I am not seeing orange. So by using different RGB amounts, the proportion, I can simulate the effect. I can regenerate the same effect in my eye so that I will perceive it as an orange again, although there is no orange wavelength coming. Do you understand? That's why we say that there are primary colors, because primary colors are based on the human eye. Most mammals have these. Şahin, falcon. Falcons have 4 different types of cells. They are also sensitive to some more ultraviolet part. So their 4 type cells estimate the some birds estimate the frequency, dominant frequency. So we make experiments. We send lambda, frequency, color, and combination of RGB. When the person says they are same, then we found equal version of the lambda. We can start from 400 to 700 and try everything, so we can generate a map. This map is like this. There is an important part with the red. So we add an offset to everybody, put this on the other side by increasing these two too. Generally, we can differentiate about 7 million colors, but can name only 11 colors in average. 2 nanometers change in the frequency is visible by the human eye. So since the RGB is a combination of all these 2 nanometers, we can see different colors. Also, each color also have levels of shade, dark and light, bright and dim. So it makes 7 million different colors. So these are directly transferred from the human eye to the TV technology and CRT and LCD technology, red phosphorus, green phosphorus, and blue phosphorus, when they excite different amount, we can create RGB, different amounts of color, and details are given in computer graphics course. Also, our eyes have black and white cells. And the amount of black and white cells is like 50 times more, I think. 100 million black and white cells. These are earlier type of cells. They are sensitive to light more. So night vision is provided by these cells. These require more light. And also the peripheral vision. These are peripheral vision. For example, if something is happening here, I see it. A line is coming to me. I can see it immediately. If somebody is looking at you from another car, you feel it, right? It is not a feeling, it is seeing. Okay? So you see it and you rotate your head, and then you realize that somebody is looking at you. Because these cells, black and white cells, are sensing them, because their response time is much faster than the color ones. Those provide us the peripheral view. For example, when you are going upstairs from the stairs, do you look down? No. Değil mi? Bakar mısınız? Bakmazsınız. But when the stairs are finished, you automatically start walking. You don't look. So this is provided by the peripheral vision. If it is dark, if the electricity went out, you can't do it. You have difficulty with the stairs. Also, you will have difficulty with the escalators. If they stop, if the escalators stop, the behavior of human is very different than the regular stair. Because the visual pattern is different than the regular stair, you will have difficulty. Therefore, wearing large glasses from the side is not good in driving because they block their peripheral vision. Also, wearing headscarves like this is very dangerous when you are driving. They have to be at the back when you are driving. Because peripheral vision is covered. Your vision is reduced. There are some incidents when they find drivers for wearing headscarves that are covering their peripheral vision in Canada. There are some incidents. The driver found guilty because he was he was covering the face like this. When you are dealing with the radio of the car, okay, or you are playing with the telephone in the car, somebody is going over you. Do you see it? You see it with the peripheral vision. So if you have glasses, hair like John Lennon, or headscarf like this, it's very dangerous because that covers. You need to rotate your eye. You need to rotate your eye all the time. Efendim. Dersteyim, tekrar arayacağım. Tamam, bye bye. Today is my birthday. Yeah. So, peripheral vision is important. It's fast. One interesting fact is, if this red signal is blinking, and I am in the room like this, my peripheral vision immediately finds that blinking. If it is not blinking, I don't see it. But if it is blinking, I see it, because these cells are sensitive to the movement. Through the evolution, or the external factors jumping to you, you need to be aware of the other things moving. So large peripheral vision is very sensitive to movement or catching the dangers. Therefore, we can use it for giving cues, giving alerts to user. With the big screen or with the multiple screens available in the house or in the car, in the environment, in the working environment, when you need to give alert to a user, when you want to give an important information, you need to blink, you need to move. So motions are seen automatically, even if you don't look at them. Göstergede babamın Renault 9 vardı. Bursa'dan geliyoruz arka arkaya. O önden gidiyor galiba, unuttum şimdi. Yıllar önce. Şak, egzozdan kara duman. Hararet yapmış. Renault Broadway'lerin klasik şeyi. Kronik sorunu, su problemi. Motor yaktı. Temperatür yükselmiş mi? Evet. Ama sürekli de temperatüre bakacak halin yok ki. İbre yükselmiş, evet. Yavaş yavaş yükselmiş. Çünkü yola bakıyorsun, peripheral vision'da görmüyorsun. Acaba motor hararet yapar mı diye sürekli de bakman lazım ki o zaman görürsün.
Belki de bakılıyor ama fark edilmiyor olamaz mı yani böyle istemez. Mesela telefon örneği içinde demişsiniz. Telefona bakarken görüyorsunuz ama
Hareket ediyor. Hareket etmesi görmezsin. Çocuk geliyor mesela önüne veya bir araba önüne kırıyor. Görüyorsun, düzeltiyorsun. Telefona baksan bile görüyorsun. Yani yeni araçlara bakıyorsun. Işık yanıyor, sönüyor, mesaj çıkıyor, bir şeyler oluyor ekranda. Kaçırmıyorsun o görüntüyü. Çünkü hareket oluyor. İbrenin yavaş yavaş artmasını görmen mümkün değil. Ancak meraklı olman lazım. Araba nasıl falan, çok güzel arabam var falan diye bakıyor olman lazım yani. Veya işte usta şoför bakar tarzında. Pilot hatasına gidiyor iş. Bakman gerekir. Böyle gidiyor. Neyse Bursa'da kaldıydı. Orada yaptırdık falan vesaire. Sonra ondan sonra bindi. Yeni araçlarda bir tane daha sonraki aracımızda oldu. Hemen fark ettik, durduk. Çünkü fark ettik. Su koyduk vesaire. Sonra hiç motorla yaptırmadık. O alarm sayesinde şeyi koruyabildik yani. Şurada bir şey vardı. Hazır gelmişken. Bunlar da önemli. Bunları anlatayım. Gözümüz renkli. Her gözden 2,5 milyon kablo beyne gidiyor. 2,5 million cables goes back from each eye. It is not 2.5 megapixels, it's more. Because there's filtering going on. But since at the beginning we were seeing black and white, our brain is wired for black and white signal initially. Color came later. Therefore, there is a center connected to black and white in the brain, and there are color separation. Those color separation didn't require additional 3 wires. It is done by modifying the existing wires. I am sure you are not familiar with the color TV technology, but think about when they invented TV, did they know that there will be color TV? No. In 1925, they invented color TV, black and white TV. When they invent black and white TV, they didn't think about color. They invented color TV around 1950s. When they invented 1950s, in 1950s there were about 5 million receivers in the United States only. So they started to make color broadcast, but the color broadcast should be also picked up by the black and white. So same broadcast must be picked up by the old receivers too. So they decided to not introduce additional color, but they put information on top of the black and white. Therefore, they did color separation like this, red, green, and yellow, blue channels. Instead of sending RGB, they sent two different signals on the existing analog signal. So combination of these signals are sent through the broadcast signal. If you are black and white old TV, you are only seeing the luminance part. You are ignoring the other part because you don't understand it. It's like a garbage to you. But if you are color, using the tree, you can extract RGB automatically. Exactly the same thing is done in the brain. So before sending to the brain, colors are encoded in red, green, and yellow, blue channel. In the TV, it's the same, so that it is backward compatible. This is understood much later than they invented color TV. So it's a coincidence. It is interesting that addition and subtraction is happening in the eye here. They happen here. And the density of the cells are per millimeter square. 180,000 cells per millimeter square. On 180,000 cells per millimeter square at the retina. The rods, black and white, and motion sensing cells are given by red. Color cells are given by the green one. So as you see, green density of the green is only for where you look at. The rest is not almost blind. On the other hand, peripheral vision is provided by the rods. Also, peripheral vision is good in dark. Color vision is good in light, in the illuminated areas. Gece bir kurt çıkarsa karşınıza büyük ihtimal şeyden görüyorsunuz. Black and white'la görüyorsunuz. Şu kısımda blind spot, they are around here. That 2.5 million optical nerve cells goes out from the eye, and that region is blind. So there is no cell in that region, and there are experiments. Write something on the paper, move it like this, and look straight. At some point, you stop seeing it. There is an experiment. I think we can stop now. I will say see you next week, but next week there is a TÜBİTAK meeting. Maybe I will change the hour to the afternoon. Do you have a class afternoon today? Yes. So if we change for 1 week, if we change the time, when do you prefer? As an alternative time. Evening. Can I do it at 5, for example? 5 to 7. 5 to 7 yaparım o zaman. Anonsunu geçerim yani. Belli de değil daha.
Hocam şu koymuşlar ama şey yok, link yok hocam. Link olmaması normal mi?
Hocam yoklama yazacak mısınız? Bugün şu hafta daha kayıtlar.
Hocam.
Bir dakika kaydı durdurayım. Evet.